If A vector, B vector and C vector are three non-coplanar vectors, then show that the points with position vectors, these three, we have three position vectors, we need to show that these three position vectors are collinear. Okay, let us begin. So first, what we'll do, we'll consider 3 points. Let's say we have the point A, point B and point C. We are also going to consider another point O, and this O is going to be the origin of a coordinate system. Now we'll have to define the position vector of these 3 points A, B and C with respect to the origin. All we have to do is join point O and point A. Similarly, join O and B and O and C with the help of a directed line segment. So here we're going to assume that OA vector. So OA vector is going to be the position vector of point A. So let's say this is denoted by A vector plus B vector plus C vector. Next, we're going to consider the position vector of point B. Here we have OB vector. Let's say this is represented by the vector 4A vector plus 3B vector. And then we have the position vector of point C. We're going to denote it by the vector OC. Now let's say this is given by 10 times A vector plus 7 times B vector minus 2 times C vector. Now we have to show that these points A, B and C are collinear. What we will do, we will take the vector AB first. Now when we want to define the vector AB, we're going to take the help of the position vector. All we have to do is take the position vector of the endpoint. This is going to be the vector OB, and from here subtract the position vector of the initial point, which is OA in our case. Now that means we will now take OB vector, that's 4A vector plus 3B vector, and from here we're going to subtract OA, which is A vector plus B vector plus C vector. Now what's 4A minus A? So that's 3 times A vector. 3B minus B, so that's going to be 2B vector. And we have negative C vector. So this is our vector AB. We're going to label this as number 1. Fine. Now what we'll do, we'll join B and C. And let's say this is a vector going from B to C. And we'll find out the vector BC. In terms of the position vector, this is simply going to be OC vector minus OB vector. So let's use the values. The OC vector is 10A vector plus 7B vector minus 2C vector. Now from here, we're going to subtract OB vector, which is 4A vector plus 3B vector. Now that gives us, so 10A vector minus 4A vector is going to be 6 times A vector. Then 7B vector minus 3B vector is going to be 4 times B vector minus 2 times C vector. So we have obtained BC vector as well. However, we see here that BC vector, but BC vector can be also expressed as 2 times. So we're factoring out 2 from each of the 3 terms on the right hand side. So we have 3A vector plus 2 times B vector minus C vector. And what is 3A plus 2B minus C vector? According to 1, this is the vector AB. So that means we have BC vector equals to some scalar, which is has a value of 2, times the vector AB. And whenever this particular criterion is met, we say that A, B and C, these 3 points are collinear. Hence proved.